Okay everyone, welcome back to Cruise class. Today we'll be looking at how we can create composite functions. Now what is a composite function? As the name suggests, composite. It simply means more than one. So a composite function is one function that is made up of more than one functions, individual functions. So you can have three functions together making one composite function. You can have two functions together making one composite function. So a composite function, once more, is basically one function that is made up of two or more other functions. Now in this example, we have one function f of x is equal to 2x minus 1, and we have another function g of x is equal to 3x plus 2. Now the first example we're going to look at is the composite function g of f of x. Now what we want to look at first is that g is on the left, f of x is on the right. So the function that is on the right is going to be the function that is in the function that is on the left. So it is right to left. So what is this? What this is saying is that f of x should be substituted into g of x. So once more, this is f of x. This is g of x. So we're going to substitute the entire f of x into the function g of x. So we're going to substitute the entire 2x minus 1 where x is in g. So what we're going to do, once more just for emphasis, we're going to substitute the entire function 2x minus 1 and we're going to put it where x is in the function gx. So it's going to be 3 times 2x minus 1 plus 2. So when we substitute 2x minus 1, instead of having x here, we're going to now have 2x minus 1, as we can see here. So it will be 3, no longer x, it is now 2x minus 1 plus 2. And then we do our regular working out. 3 times 2x is equal to 6x. 3 times minus 1 is equal to minus 3 plus 2. Then we have 3x. Minus 3 plus 2 is giving us negative 1. So therefore, 6x minus 1 would be the composite function g of f of x. Now, in the other example we're going to look at f of g of x. So in this case, g of x is on the right. So therefore, this is telling us that g of x is going to be into the function f. So we're going to substitute g of x into the function f of x. So if this is g of x, we're now going to put g of x into f of x. So where x is in f of x, we're now going to put the entire function for g of x. So we're going to replace x here with 3x plus 2. That's what we're going to do, because g is now the one that is going to be in f. So when we replace, this is what we end up having. Instead of saying 2x minus 1, we now have 2 g of x minus 1. So it will be 2 times 3x plus 2 minus 1. Regular calculations, we see 2 times 3x, 6x, 2 times 2, 4 minus 1. So therefore, 6x plus 4 minus 1 is equal to 6x plus 3. So therefore, this will be the function f of g of x. And as you can tell, g of f of x gave us 6x minus 1. However, f of g of x gave us something different, 6x plus 3. So a point to note is that composite functions are not commutative, meaning if we were to rewrite them, they will not be equal to the same. So therefore, g of f rather, is not necessarily equal to f of g.